Hi, it's Mrs. Leeson on a rainy Sunday afternoon, and ready to talk to you about 6.1a lesson, Angle Relationships in Triangles and Other Polygons. So the first thing that we're going to do is activity number 1, which is deriving a formula for the interior angle sum of a polygon. And you can see the first step is to put a dot on one vertex in each figure. This isn't going to work on a triangle. There's only one vertex and you're going to be drawing diagonals. But let me show you what that looks like on the pentagon. So from the pentagon that I've drawn my vertex, and it doesn't matter which vertex you pick, I'm just going to draw, and I'm drawing freehand, a diagonal, all the diagonals, possible diagonals from that vertex. And you can see I have separated this pentagon into 3 triangular shapes. And we know that the sum of the angles in a triangle is 180 degrees, no matter how big, how small, or what shape that triangle is. So just looking at that figure, I'm going to scroll down to the table, and you can see in the table, if it's a 3-sided figure, there's one triangle in it. The interior angle sum is 180 degrees. For the 5-sided figure, the pentagon that I just showed you, we were able to create 3 triangles, and 3 times 180 is 540 degrees. So that's what I would like you to do for all of these figures. Please complete the table. Scroll down. I'm going to scroll down. You're going to finish this entire page. And the goal here is number 3. Derive a formula for the interior angle sum of a polygon with n sides. So I'd like you to use n in your formula, please. I'm going to ask the sub to pause the video, and I'm going to ask her to give you 15 minutes. If you finish sooner than that, we'll just get started again, and she can press play. So go ahead and pause the video, please, and class, complete this entire page 22. Okay, welcome back. I'm guessing that took probably 8 minutes. You guys are fast. This is what your images should have looked like, and you're very quickly realizing that however many sides there are to the figure, there are 2 less triangles for every shape. So when we end with that final 8-sided figure, there were 6 triangles that could be formed, and all we're doing is multiplying 180 degrees times the number of triangles to find out the interior angle sum. And again, those interior angles are the ones on the inside of the figure, which probably makes perfect sense to you. So scrolling down the page, the final result was number 3. What is the formula? And I hope you use the letter N. This is the formula that I'd like you to use. 180 times the quantity n minus 2, where n is the number of sides in the polygon. So starting with that point, on the next page, number 4, 5, and 6, please start with that formula, and I guess I'll just show you the first one. And then beneath that, you're going to show your substitutions. So starting with the formula, and this is again a formula that's known all around the world, n minus 2, 180 times 7, and the final answer there is, I'm getting my calculator out in case you can't tell, 1,260 degrees. Be sure you put that degree symbol and box your answer. When you finish those in 2 minutes, we'll go ahead and start the video again and take a look at some of these true and false questions. Okay, time to pause the video one more time. And by the way, I have a maximum of 15 minutes, and it's been 4 minutes and 8 seconds. So I'm going to have to talk fast. Please pause the video now. Okay, so that was straightforward enough. And remember, these are the formulas for showing the sum of the interior angles of any figure. Now we're going to finish the rest of the page. I'm going to demonstrate one problem in number 7. This is all about explaining your reasoning. So numbers 7 through 13 are true and false problems. Explaining your reasoning is the key. This is in words, not in pictures. An isosceles triangle can also be a right triangle. So now you need to think, is this true or is this false? Isosceles means that 2 sides are congruent. So I'm just going to sketch this. When I sketch, I'm going to include everything that's in the image, and I have to sit here and think about this. And so this is obviously, to me anyway, a true statement, because as we spoke about last week, this angle controls the length of this side, and the opening of this angle controls the length of that opposite side. So there is a case where an isosceles triangle can also be a right triangle, and so I would have to now explain that in words. True, because two equal sides means two equal angles. And in a right triangle, that would be 45 degrees, 45 degrees, and 50 degrees. 90 degrees. Oh boy. Okay, there we go. So that's the kind of reasoning and explaining that I'd like you to do for numbers 7 through 13. And then number 14 says always, sometimes, or never, meaning true, always, sometimes, or never true. If sometimes, then explain why. So remember, if you say sometimes, then you must give two examples. You want to give an example when it is true. Give example of true and false if your answer is sometimes. So your next task is please complete numbers 8 through 17. We'll pause the video and we'll see if you get the answers right. And please chat in your groups because these aren't as obvious as you might think. Okay, I'm going to suggest 10 minutes on the timer, and if you need more, just talk to your sub about that. Pause the video, please. Okay, here are the answers to numbers 8 through 13. I'm going to pause the video. I'm going to ask the sub to pause the video so you can process this and maybe read it out loud. This is an example of using logic as well as learning and mastering your vocabulary. So please pause the video and then I'll give you the answers to the last 4 problems. Okay, hopefully you had some really good discussions and disagreements and arguments. My answers are right, and if there's anything that you'd like to talk to me about when I return, just put a little star next to that problem. Here are the answers to the last 4 problems. Number 14, parallelograms are always quadrilaterals, which means it's a 4-sided figure. Number 15, rectangles are sometimes squares. Don't get confused by the fact that squares are always rectangles. Rectangles are sometimes squares, not always. All 4 sides have to be congruent for that to be true. Number 16 was the only always. Well, no, that's not true. Number 16 is always. An equilateral triangle is always a regular polygon, and the definition of regular means that all sides and angles are congruent. And finally, number 17, rectangles are always parallelograms. The definition of a parallelogram is a 4-sided figure having 2 pairs of parallel sides. All right, so hopefully you got all those correct. Anything you didn't get correct, put on your list of things to study. And then if you'll turn to page 24, I'm going to demonstrate what your work needs to look like for the first problem, and then with your group you're going to finish the rest of these problems. So this activity number 2 says finding the missing angles of polygons, and you can see finish reading the directions. Using each figure below, answer the following questions. Note, figures are not drawn to scale. And again, what that means is, even if the angles look to be the same measure visually, you don't pay attention to that, you just pay attention to the notation or information that you're given in the figure. So looking at number 18, I see a triangle with 3 angles. The first angle A, it measures x degrees. The second angle B measures 3x degrees. And the third angle C measures 2x minus 9 degrees. And the directions say, find x and the measure of angle ABC, the measure of angle BCA, and the measure of angle CAB. So the first piece of information that we have here is that because it is a triangle, the sum of these three angles is 180 degrees. You are going to write an algebraic equation showing that the measure of angle A plus the measure of angle B plus, and I'm putting this in parentheses to show that it's the measure of angle C, is 180 degrees. Notice I don't put the degree symbol there. This is just an equation without units. And just watch this while I do it, and then you can pause the video, copy it, and finish the last three. So I'm going to combine like terms. I've got 4x plus 2x is 6x. 6x minus 9 equals 180. When I add 9 to each side, I get 6x equals 189. And when I divide each side by 6, I find that x equals 31.5. So I've done the first piece, I've found x. So the measure of angle, and I'm just going to call this the measure of angle A. I do not need three letters to name that angle. The measure of angle A is 31.5, and here's where the degree symbol comes in. The measure of angle B is 3 times that value, which is 54 degrees. Strike that, reading in the wrong answer. 3 times 31.5 is 94.5 degrees. And then finally, 2 times 31.5 minus 9 says that the measure of angle C is 54 degrees. That's the one that's 54 degrees. Just looking at the wrong answer. Okay, so that's what your work needs to look like. Please show an algebraic equation and solve it algebraically, and then tell me the measure of all of the other angles. So you can pause the video now, copy down this information, and please complete 19 through 21. That should take about 10 minutes. So put 10 minutes on the clock and start the video again when you're finished. So please pause the video now. Okay, I hope you had fun solving these equations and using your polygon formula after number 19. Number 19, x equals 19, and you can see that angle A is 91 degrees, angle B is 50 degrees, and angle C is 39 degrees. Once you get to number 20 and 21, you have to first realize that the figure is a four-sided figure in number 20, so this angles add up to 360 degrees. X equals 39, and the measures of the angles are 78 degrees, 90 degrees, 149 degrees, and 43 degrees, respectively. Number 21, five-sided figure, also called a pentagon. The sum of the angles is 540 degrees. As a result, x is 50, and the angles in alphabetical order are 93, 140, 52, 144, and 111 degrees, respectively. That's the end of the lesson. So I made it under my 15-minute time limit. You may pause the video. The next thing that we're going to be working on is 6.1b lesson, and this is what you started on your own using the GeoGebra file at home for homework. So please take that material out next for the next lesson. Thank you.